Hello my dear students, welcome to our physics online class. Today I am going to discuss about AC generator from the chapter electromagnetic induction and alternating current. Right. We know that there are three methods of producing induced EMF already taught in the previous classes. Right. There are three methods by changing the magnetic field, by changing the area enclosed by the coil, by changing the orientation of the coil with respect to the magnetic field. So these three are methods of producing induced EMF, right? So one of the method of producing induced EMF, the induced EMF is produced by changing orientation of the coil or orientation of the conductor with respect to the magnetic field, with respect to the magnetic field, right? Okay, practical application of this method is AC generator. AC generator. So today we are going to discuss about AC generator, right? And generator is also called alternator or dynamo. Generator is also called alternator or dynamo, right? And generator is an electrical device. It is an electrical device. It was first devised by a Yugoslav scientist Nikola Tesla. A Yugoslav scientist Nikola Tesla was the first one devised generator. Generator is also called alternator or dynamo. Alternator or dynamo, right? And actually, the generator is a energy conversion device. It is a energy conversion device, right? Generator is also called alternator. Generator or alternator or otherwise called dynamo. Dynamo. It was first devised by a Yugoslav scientist Nikola Tesla. Nikola Tesla. It is one of the electrical device. It is one of the electrical device, and also it is one of the energy conversion device. Energy conversion device, because it is used to convert mechanical energy into electrical energy. Okay, generator converts mechanical energy into electrical energy. Electrical energy. So generator converts mechanical energy into electrical energy. So that is why AC generator is one of the energy conversion device. Energy conversion device, right? The mechanical energy given to the AC generator is used to rotate the coil or magnet in the AC generator. Okay, magnet or coil in the generator, which becomes converted into electrical energy. It becomes converted into electrical energy. Okay, the mechanical energy is given to the generator. That mechanical energy is used to rotate the coil or magnet in the generator. It becomes converted into electrical energy. So the generator is used to convert the mechanical energy into electrical energy, right? We know that all the electrical goods and electronic goods require electricity. Just to imagine our life without electricity. It is impossible to run our life without electricity, because our basic need is electricity. The electricity can be generated or can be produced only with the help of a generator. So generator is a very important device which is used to generate electricity or electric power. So all the electrical appliances and electronic appliances is worked only with the help of electricity, right? So it can be generated by using generated or produced by using generator, right? So one of the generator is AC generator. The generator which is used to produce or which generate alternating current is called AC generator. There are two types of a generator, AC generator and DC generator. The generator which produces alternating current means then it is called AC generator. If it produces direct current means then it is called DC generator. So in this session we are going to discuss about only AC generator. Okay, all the generator invariably, both the AC generator and the DC generator converts the mechanical energy into electrical energy. The generator was first devised by a Yugoslav scientist Nikola Tesla. Right. And next we go for the working principle of a generator. Okay, so this is introduction of a generator. Now we go for principle. The working principle of a generator is electromagnetic induction. Electromagnetic induction. Electromagnetic induction is a basic principle of generator. Basic principle of generator or AC generator. What is meant by electromagnetic induction? Okay, electromagnetic induction is one of the phenomenon. The phenomenon of producing induced EMF when the magnetic flux associated with the conductor or the magnetic flux associated with the coil or closed circuit changes. It was first discovered by Michael Faraday. So Michael Faraday was the first one that discovered electromagnetic induction. Electromagnetic induction is a phenomena by which the induced EMF is produced by changing the magnetic flux associated with the closed circuit. So whenever the magnetic flux linked with the closed circuit changes, an EMF is produced. So that phenomenon is known as electromagnetic induction. It was first discovered by Michael Faraday. The working principle of AC generator is electromagnetic induction. Right. The induced EMF magnitude is given by Faraday's laws of electromagnetic induction. Okay, according to Michael Faraday, whenever the magnetic flux linked with the coil or closed circuit changes, an EMF is induced in it. That phenomenon is known as electromagnetic induction. The magnitude of induced EMF is given by Faraday's laws of electromagnetic induction. Michael Faraday, in order to demonstrate the electromagnetic induction phenomenon, he was conducted several experiments. Okay, the results obtained from all the experiments are summarized as Faraday's laws of electromagnetic induction. Okay, there are two Faraday's laws of electromagnetic induction: Faraday's first law and Faraday's second law. Right. What is Faraday's first law? According to Faraday's first law of electromagnetic induction, whenever or when the magnetic flux linked with the closed circuit changes, an EMF is induced in it. Whenever the magnetic flux linked with the closed circuit changes, an EMF is induced in it. The EMF loss as long as the change in magnetic flux continues. The EMF loss as long as the change in magnetic flux continues. So this is Faraday's first law of electromagnetic induction. Right. Next, Faraday's second law of electromagnetic induction. According to Faraday's second law of electromagnetic induction, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linked with the coil. The magnitude of induced EMF produced in the coil is directly proportional to the rate of change of magnetic flux linked with the coil. It is given by the relation E is equal to d pi divided by dt. Pi, magnetic flux. Generally magnetic flux is denoted by the letter pi. D pi divided by dt is called rate of change of magnetic flux. The rate of change of magnetic flux. The magnitude of induced EMF produced in the closed circuit is always directly proportional to the rate of change of magnetic flux linked with the coil. The rate of change of magnetic flux linked with the coil, or E is equal to K into d pi divided by dt, where K is a constant of proportionality whose value is 1. Therefore, E is equal to d pi divided by dt. Suppose the closed circuit contains n number of turns, then the magnitude of induced EMF is given by E is equal to n into d pi divided by dt. N into d pi divided by dt, or otherwise E is equal to n of pi 2 minus pi 1 divided by t. Pi 1 initial magnetic flux and pi 2 final magnetic flux after the time interval of t. Okay, if the time, if the magnetic flux is changes with the time, which is linked with the, the magnetic flux is linked with the coil or closed circuit, and EMF is induced in it. Suppose if the coil contains n number of turns, then the magnitude of induced EMF produced in the coil can be calculated by using this formula. E is equal to n of pi 2 minus pi 1 divided by t. Right. So according to Faraday's law of electromagnetic, second Faraday's law of electromagnetic induction, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linked with the coil. So the magnitude of induced EMF is given by Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. Right. The direction of induced EMF is given by Fleming's right-hand rule. Fleming's right-hand rule. Right. What is Fleming's right-hand rule? According to Fleming's right-hand rule, stretch the first three fingers of our right hand. Stretch the first three fingers of our right hand. They are mutually perpendicular to each other. They are mutually right angles to each other. The angle between thumb finger and forefinger should be 90 degree. And the angle between forefinger and middle finger should be 90 degree. Similarly, the angle between middle finger and thumb finger should be 90 degree. So we need to stretch these three fingers of the right hand like this. Right. So according to Fleming's right hand rule, stretch the first three fingers of our right hand. They are mutually perpendicular to each other. Right. Among the three fingers, first finger represents the direction of a magnetic field. Which is first finger? Forefinger. Okay, forefinger represent the direction of a magnetic field. Direction of magnetic field, right? And second finger represent the direction of motion of the conductor. The direction of motion of the conductor. Here, the second finger should be thumb finger. Thumb finger. And third finger represent the direction of induced current or direction of induced EMF. The direction of induced current or direction of induced. So, which is third finger, middle finger. So first finger forefinger, second finger thumb, and third finger middle finger. Forefinger represents direction of magnetic field, thumb finger represents the direction of motion of the conductor, and middle finger represents the direction of induced EMF or induced current. Magnitude of induced EMF is given by Faraday's laws of electromagnetic induction, and the direction of induced EMF is given by Fleming's right-hand rule. Fleming's right-hand rule. So Faraday's laws of electromagnetic induction and Fleming's right-hand rule are already discussed in the previous classes. Right. Already I told, generator is also called alternator. It was first devised by Yugoslav scientist Nikola Tesla. Alternator is an energy conversion device because it is used to convert mechanical energy into electrical energy, and working principle of generator is electromagnetic induction. Electromagnetic induction. Okay, what is electromagnetic induction? When the magnetic flux linked with the closed circuit or coil or conductor changes, and EMF is induced in it. In the case of a generator, there is a conductor. There is a conductor, and also there is a magnetic field. The relative motion between the conductor and the magnetic field changes the magnetic flux, which is linked with the conductor. So an EMF is induced in it. An EMF is induced in it. So that phenomenon is known as electromagnetic induction. The basic principle or working principle of a generator is electromagnetic induction. The magnitude of induced EMF is given by Faraday's laws of electromagnetic induction, and the direction of induced EMF is given by Fleming's right-hand rule. Fleming's right-hand rule. Right. Now we go for construction of AC generator. Construction of generator or AC generator. Construction. There are two major parts in the AC generator. First one is starter, and the second one is rotor. Starter and rotor, these two are two important or main parts of generator. So what are the two important or main parts of generator? Starter and rotor. Starter and rotor. Right. Here the starter is a stationary. It is a stationary part of the generator. Okay, which is the stationary part of the generator? Starter. So that is why it is called starter. It is always stationary. It is always a rest. It is always a rest. So that is why this part is called starter. It is always stationary. Right. And second part, main part of the generator is rotor. Okay, it is a rotating part. So there are two major parts of generator. They are starter and rotor. Starter is a stationary part of the generator because it is always stationary. And another part of the generator is a rotor. It is always a rotating one. Okay, the rotor is always rotates inside the stator. Okay, it is always rotates inside the stator. Right. So these two are the two important or major parts of a generator. Major parts of a generator. Right. Invariably, in all the commercial generators, in all the commercial type of generator consist of armature winding and field magnet. Okay, invariably all the commercial type generator consist of armature windings and field magnet. Armature windings and field magnet. The armature windings is always wound on starter. Armature windings is always wound on starter, whereas field magnet is always wound on rotor. Okay, so all the commercial type of generator consist of armature windings and field magnet. The armature windings is wound on starter, whereas the field magnet is wound on rotor. Right, so starter and rotor, these two are the major parts of a generator. Major parts of generator. Right. So next we explain about the starter. Already told, the starter is a stationary part of a AC generator. It consists of armature windings. Okay, it consists of armature winding. And there are two main components in the starter. One is a starter core and second one is armature winding. Starter, rotor, these two are major parts of a generator. The two important components of a starter are starter core and armature winding. Starter core and armature winding. Right. Starter core is a cylinder type of core. It is a cylindrical type of core which is made up of either iron or steel alloy. Okay, the starter consists of starter core, okay, which is cylindrical in shape, which is made up of either iron or steel alloy. Either iron or steel alloy, right? So this cylinder is completely insulated. The cylinder core is completely insulated in order to reduce the eddy current loss. Okay, in order to reduce eddy current loss, the cylinder core is completely insulated, and which is made up of either iron alloy or steel alloy. So that cylindrical core is called starter core. Starter core is one of the main component of a starter. Right? And the second one is armature winding. Armature winding is nothing but a rectangular coil or simply coil. A cylindrical type core is called starter core, and a rectangular coil is nothing but armature winding. And one more thing, in starter core there are a large number of slots are cut. The large number of slots are cut, okay, in order to accommodate the armature winding. In order to accommodate the armature winding, there are large number of slots are cut in the inner surface of the starter core. In the inner surface of the starter core, there are large number of slots are cut in order to accommodate armature winding. Okay, accommodate armature winding. So what is armature winding? The armature winding is nothing but a coil. Okay, this armature windings is wound inside the slots which is made at the interior part of the starter core. Okay, here starter core and armature winding. So these two are main components of a starter. Main components of a starter. Starter core is a cylindrical core which is made up of either iron alloy or steel alloy. Okay, and there are a large number of slots are cut inside the or inner surface of the starter core in order to accommodate armature winding. The armature windings are nothing but a rectangular coil. So these coils are placed in the slots, okay, which are made at the inner surface of the starter core. The inner surface of the starter core. So starter core and armature winding. So these two are main components of a starter. Starter is one of the major part of, alternator. Major part of alternator. Right. Next, we go for a rotor. What is rotor? The rotating part of the alternator which has field magnet in it, is known as a rotor. Okay, rotor is one of the, it is a rotating part of the generator. Right. This rotor consists of magnetic field windings. So rotor is a rotating part of the generator. It consists of magnetic field windings. Okay. Don't confuse between armature windings and magnetic field windings. The windings which is wound on the salient poles of the rotor is called magnetic field windings. Okay. The windings in the stator are called armature winding. Okay. The armature windings is always present in stator, whereas the magnetic field windings is always present in rotor. So rotor is a rotating part of the generator. It consists of magnetic field windings. Right. In the rotor, there is salient poles on which the magnetic field windings are wound. Okay, magnetic field windings are wound on the salient poles, right? And the electrical contact, the salient poles can be magnetized with the help of a DC source. By using DC source like a battery or the electrical cell, we can magnetize the salient pole present in the rotor. Okay, the rotor consists of a magnetic field windings which are wound on the salient poles. It can be magnetized with the help of a DC source. Right. This is a simplified form of a generator. Already I told there are two major parts in the generator. One is a starter and another one is a rotor. Okay, starter is a stationary part of the generator. Okay, so this is starter. Okay, it is a stationary part, right? So this is, the core of one of the important component of a starter is a starter core. So the starter, this is starter core. The starter core is made up of either iron or steel alloy. Right? And there are a large number of slots are cut in the inner surface of the starter core. Okay, large number of slots. Okay, this is armature slot. Okay, this is slot. So, okay, likewise, many slots are made or cut in the inner surface of the starter core. Okay, why? To accommodate the armature winding. The armature windings are placed in this slot. So that is why it is called armature slot. So this entire, the outer part of this diagram is called starter. Okay, it consists of two major parts. One is two important component. One is starter core, and the second one is armature winding. So here armature winding is placed in this region, and this is inner part of the starter core, and this entire region is called starter. So this is stationary part. The stationary part of the generator is called starter, right? And the second major part of the alternator is rotor. So it is a rotating part. The rotor consists of magnetic field windings, Alternator. So this is magnetic field winding. Okay, this magnetic field windings is wound on salient pole. Okay, this part is called the salient pole. Right? And this salient pole is magnetized by using DC source. By supplying DC current, to this armature winding, the salient pole gets magnetized. It becomes a magnet. Okay, so one end becomes a north pole and another end becomes south pole. So this is a salient pole. Salient means projection. Okay, it is a projector like this on both sides. Right? So this salient pole gets magnetized or can be magnetized with the help of a DC source. Right? And the connection between the electrical connection between the magnetic field windings and DC source is given by brushes which is made up of a carbon. That is why they are called carbon brushes. This carbon brushes is used to connect the magnetic field windings and DC source. By supplying DC source to this armature winding, magnetic field windings through this carbon brushes, the salient poles gets magnetized. The salient pole gets magnetized, right? So this entire part is called rotor. The outer part of this diagram is called stator, and the inner part of the diagram is called rotor. The rotor consists of a salient pole on which magnetic field windings are wound, and these windings are connected to a DC source with the help of carbon brushes, right? And this magnetic field windings, I mean the ends of the armature windings is connected to two slip rings or sliding contacts. The ends of the magnetic field windings is connected to a sliding contacts is called slip rings, right? Here these two are slip rings. The ends of the magnetic field windings is attached to this slip rings, right? And this slip rings is connected to or attached to a shaft. A shaft is nothing but a conducting rod, okay, to which the slip rings are attached. And this shaft is made to rotate externally. Whenever the shaft rotates, the slip rings and along with this salient poles also rotates, right? So this is a shaft to which the two sliding contacts or slip rings are attached or fixed. Whenever the shaft rotates externally, these slip rings and along with the salient poles also rotates. So this rotating part of the generator is called rotor. The stationary part of the generator is called stator. So stator and rotor are two major parts of generator, okay, in both AC generator and also DC generator. Right, next topic, advantages of stationary armature and rotating field alternator. Actually there are two types of alternator. One is AC generator, another one is a DC generator. A generator which generates alternating current is called AC generator. A generator which generates or which produces a DC current, I mean direct current, is called DC generator. So depending upon the nature of the current obtained from the generators are classified into two types, AC generator and DC generator, right? Depending upon the construction or based on the construction, the generator are of two types. One is stationary armature and rotating field alternator. In this alternator or in this type, the armature is stationary and magnetic field is rotates. Armature is stationary and magnetic field is rotate. Such type of alternator is called stationary armature and rotating field alternator. And the second type, stationary field and rotating armature alternator. Okay, second type is stationary field and rotating armature alternator. In this type, magnetic field is stationary and armature is rotating. So depending upon the construction, the alternator are of two types. One is stationary armature and rotating field alternator, and the second one is stationary field and rotating armature alternator, right? So comparing these two alternator, the stationary armature and rotating field alternator has more advantages. Okay, some of the advantages of stationary armature and rotating field alternator is given our book. So first advantage, the current can be drawn directly from the fixed terminals on the stator without use of carbon brushes, right? We know that carbon brushes is used to make a physical contact between magnetic field windings and DC source. In this type of alternator, without the use of carbon brushes, we can draw electric current from the generator. So this is a main advantage of in this type of alternator. Right? Second advantage in this type of alternator is the insulation of armature winding, the insulation of a stationary armature winding is easier. Here, in this type of alternator, the armature is always stationary. So, the insulation made in this type, made on the stationary armature winding is very easier. But in the rotating type armature alternator, okay, difficult to insulate the rotating armature winding. rotating armature winding. So this is also another advantage in this type of alternator, right? Insulation made on the stationary armature windings is very easier because this armature is always stationary, right? Right. Third one, in the stationary armature and rotating field alternator, the number of sliding contacts, that is number of slip rings are reduced. Number of slip rings are reduced. That is very less number of slip rings or sliding contacts are required in this type of generator. But in the case of stationary field and rotating armature alternator need large number of sliding contacts or a large number of slip rings, right? So this is also one of the main advantage in this type of alternator, right? And the last one, the armature windings can be constructed more rigidly. In this type of alternator, the armature windings are constructed more rigidly, okay, in order to prevent the deformation produced in the armature winding due to some mechanical stress. Okay, from the mechanical stress, to prevent the deformation of the coil, the armature windings are constructed more rigidly. So these four are important advantages of stationary armature and rotating field alternator when we compare to stationary field and rotating armature alternator, right? Right, let us recall from the beginning. Generator is also called alternator or dynamo. It was first devised by a Yugoslav scientist Nikola Tesla. And generator is an energy conversion device. It converts mechanical energy into electrical energy. Right? The working principle of generator is electromagnetic induction. Right? Already I told you what is meant by electromagnetic induction. The EMF, the phenomenon of producing induced EMF, whenever the magnetic flux or magnetic field associated with the closed circuit changes. The induced EMF magnitude is given by Faraday's laws of electromagnetic induction. It is given by the relation E is equal to N of pi 2 minus pi 1 divided by T, where N number of turns in the coil, phi 1 initial magnetic flux, pi 2 final magnetic flux, right? So depending upon the magnetic flux changes with respect to time, the magnitude of EMF induced in the coil is changes. So Faraday's laws of electromagnetic induction is used to calculate the magnitude of induced EMF. The direction of induced EMF is given by Fleming's right-hand rule. Okay, next, construction. There are two major parts in the AC generator. One is starter and another one is rotor. Starter is a stationary part, whereas rotor is a rotating part. Starter consists of two major components. One is a starter core and another one is armature winding. Starter core is cylindrical in shape, which is made up of either steel alloy or iron alloy. Okay, in this cylinder is completely insulated, okay, in order to prevent the eddy current loss. The cylindrical core is completely insulated, and there are large number of slots cut in the inner surface of the starter core, on which or in which the armature windings are placed. What is armature winding? Armature winding is nothing but a coil. Okay, armature windings is nothing but a coil. Next, rotor. Rotor is a rotating part of the generator. It consists of magnetic field windings, and these windings are placed on the salient pole. The salient pole is magnetized by using a DC source. The physical contact between a DC source and magnetic field windings is done by two brushes called carbon brushes. Right? The carbon brushes is used to make a physical contact between magnetic field windings and the DC source. Right? And the ends of the magnetic field windings is connected to two sliding contacts called slip rings, and the slip rings are attached to the shaft. So whenever the shaft rotates, the slip rings and the magnetic fields also rotates. Okay, so this entire part is called rotor, right? And advantages of stationary armature and rotating field alternator. Okay, there are four advantages. First one is current is drawn directly from the alternator without use of carbon brushes. Okay, this is a main advantage in this type of alternator. And second one, the insulation on the stationary armature windings is very easier, right? And third one is the number of sliding contacts, that is the number of slip rings is reduced in the case of stationary armature and rotating field alternator. And the last one is the armature windings can be constructed more rigidly. In this type of alternator, the armature windings are constructed more rigidly in order to prevent the deformation, okay, due to some mechanical stress. From the mechanical stress, to avoid deformation, the armature windings are made or armature windings are constructed more rigidly. So these are advantages of which alternator? Stationary armature and rotating field alternator, right? So these things are being discussed in this session, right? So thank you, students. Just you go through this topic. If you have any doubt, okay, you call me or send a message to my WhatsApp number. Okay, thank you. We will see you in the next class.